So hi, everyone. Happy to be here today. I'm going to talk about how we use real-time data within Parity to stabilize Polkadot and understand how stable it is. Before starting, I'll share a few words about what Polkadot data actually is, how we work with it, and why we actually need it. So Polkadot data is used to answer questions around how many people are using the product, where we can see all the transactions that are happening within the ecosystem, who voted on what in the case of OpenGov, and what we can optimize for and what we can do. So a blockchain produces blocks, these blocks are captured, and this is what essentially makes up the data. One block usually contains events, extrinsics. It's essentially data types that we can use to understand what happened in that specific block at that specific moment in time on the blockchain. It requires a lot of custom logic to decode to understand what actually happened. So it's a bit complicated to get there. Now, a lot of libraries exist to help with that decoding. Some of them are called Polkadot.js API, PAPI, SubXT, PySubstrate interface, that you would write custom logic, custom code on to decode and get access to the contents of the block or the state of the blockchain. Now, whenever there is an upgrade, which is something that is specific to the Polkadot ecosystem, you can actually upgrade the blockchains while they are running. You get to a new version, I would say, of that chain, or a new version of the blocks produced by that chain. This means that the logic that you wrote before for parsing those blocks might be outdated, and you would need to extend that to be able to understand the new incoming blocks compared to the old ones. So Polkadot data is a little bit complicated because you have a lot of chains, a lot of different ways, I would say, to decode and understand the blocks, and a lot of different contents of the blocks. I made this joke on the right to prove, make the point about all the steps that you need to go through to actually get a good understanding of what is inside the blockchain. Another point to mention, it's not easy to maintain. Very often, teams in the ecosystem reach out to us and tell us, how can we solve this once and for all? How can we make sure that if I write the code today, it will still work tomorrow, especially for decoding the blocks? This even gets more complicated if we grow the number of chains and grow the number of interactions between the chains. All of that contributes to a lot of complexity, especially if we consider an ecosystem that would be growing 10x, 100x, or 1000x. What kind of solutions do we have to actually get access to the data and understand what's going on in the ecosystem? We would need a system that is real-time, resilient, low cost, and understand the relationship of having access to that data with stabilizing Polkadot. Essentially, if we understand what is going on in the blockchain, we can make the difference between what is going right and what is going wrong, what is not supposed to happen. And the solution to that is essentially data engineering, which I will explain to you about in a little bit. So I'm Karim. I'm the head of product engineering department here at Parity. It's a team made of data team, DevOps team, automation, and success. And I'm French, German, English, Arabic. I put some links in there. The favorite one would be GitHub. If you follow me there, you can have access to the latest updates of what we're building and doing and providing to the ecosystem. Also, I maintain a public website called Data with Rust if you want to learn to do these things using Rust. But you don't have to. So what is Polkadot? So Polkadot is a layer 0. It's a blockchain that provides security for other blockchains. And it's commonly called the powerful, secure core of Web3. Polkadot is also a decentralized ecosystem of actors that participate in building and interacting within Polkadot. It's an evolving ecosystem, as I said, because you can write code to actually update and upgrade the chain while it's running. To understand Polkadot, our teams previously built a solution called Dot Lake, which is, I would say, a data lake built on top of GCP, Google Cloud Platform, to store all those blocks and make this information accessible under an analytical data set kind of thing. So we make statistics, we view how many users are actually active on the chain, and we do these reports on a monthly, weekly basis. Not something that is real time, but something that still provides more insights than not knowing what is going on. This has full coverage of the ecosystem and has very marginal cost to run and operate. Also, please follow us on Twitter at @DotLakeXYZ. We'll share some insights, we'll share some things, and we're receptive to the ecosystem. If you have a new chain that you're starting, let us know. We'll add it in for free, and you'll get these insights also as well. OK, so stabilizing Polkadot needs a little bit more than just having an analytic data set that you can have a look at after the fact. So you might need something in real time to understand the runtime upgrade that I'm applying right now. How is it affecting the system? What changes does it bring with it? It's part of a huge initiative started by Oliver TY on the forum to understand what products or what things we can put in place to help stabilize Polkadot. This includes writing end-to-end tests. This includes the presentation that Pierre Robert shared this morning. And this monitoring initiative that I'm showing you is a little part of it that contributes in showcasing and showing right away what is wrong and giving developers the tools to debug whatever's going on. So what do we know? What do we not know? What are things we want to monitor and understand to be able to stabilize Polkadot? Typical things are all parachains producing blocks? Is a block slower than any other? Or is something unusual happening on a parachain? As I said before, what is the impact of the latest upgrade on the network? How can we quantify that, measure that to react as early as possible? Similarly, we can also write a few, I would say, automations to understand if something weird is happening. If some weird activity is happening on a bridge or something like that, we should be able to do that without any overhead, despite the chain being upgradable. So as I like to say it, maybe .lake is the upper part of the iceberg. The bottom part is what this initiative would enable. So the time is now to go real time with our systems, especially as we have a lot of chains in the ecosystem. The limitations of the delayed analytical data just can tell us what happened wrong last week or in the last hour. We need to know what happened in the last 5 minutes and what we can do about it. The current, I would say, initiatives or people that try this out base their stack on Grafana, Prometheus. For those who know what these tools are, they're based on a pull approach. So every X seconds, you ask the chain, was there anything new? And then you persist that, store that, and try to add your logic after you stored the blocks. This is not flexible because this suffers from the issue that when the chain upgrades, you need to upgrade your scripts before the fact. Also, developers are not keen in using SQL or Prometheus query language to debug and make their own queries for what's wrong. Because we cannot account for everything that can happen wrong, so some queries need to be interactive and written afterwards. So what do we need? We need to pull data from chains in real time. This needs to be resilient to upgrades. Responders who investigate these issues should have immediate access to data, the raw data and the transformed data, and they need to be able to find and define their own queries, right? These are examples that I put on screen for why we actually need this. On the left, you see that there was some issue in certain transactions, and it took 13 days to be detected. This is typically what analytical systems suffer from. You need to know what you're looking for to see that something is wrong, right? In the middle, these are forum posts and a GitHub issue where developers themselves express the need for systems that enable these sort of things. And on the right, lately, I don't know if you saw it on Twitter, but there was an issue in Bifrost that was resolved in 5 hours. The team did a great job resolving that, but providing them the tools might help them do that even better in the future. So why do we need it? Again, recap. So very early detection, providing guarantees, measuring our success, our SLOs if you want, and improving Polkadot in the long term. So how? We built a solution called .Sentry. So Sentry is something that watches over things, right? It's an ecosystem-wide real-time monitoring that you can run on a budget. So you don't need to break the bank to be able to monitor 100 blockchains in parallel, right? The goal of the system is to have all the chains, get the data, and give access to the developers and have that fast, cheap, simple, robust, and most importantly, open source for anyone to run on their own if they don't want to rely on external people providing that data for them. The constraints that we have additionally is we want this to scale to 75 networks or more, including the test nets, so let's say 100, rounded up. Assuming we have 1 block every 6 seconds, the block size is limited to analytical data, so a little bit less than 5 megabytes. Non-sustained load, this means it's not every second that there is a new block, every 6 seconds, as I described. And user want the data, not deal with writing code, scale codecs, or deal with node endpoints, get access to an RPC node or whatnot. We need to smoothen the path from the block is produced and the data is available on the desktop of or the laptops of the developers. There are many approaches how we can solve this. As I said, there are centralized, decentralized logging initiatives that would involve tools like Prometheus, Loki, where we can pipe the contents of the blocks, perhaps make them accessible for people. There are tools like batch processing, like .lake. We can just reduce the time it takes for .lake to operate. Right now, it's every hour we get new data. We can turn it down to 10 minutes every minute. But still, this wouldn't provide the same thing because you would still need to run the queries every time. You don't get a real-time notification that something's happened. Or you can use something called publish-subscribe logging. This is what I will talk about. The main, I would say, constraint is we want a system that will horizontally scale. So if we have more parachains, it wouldn't be an issue that we use the same system to monitor those chains too. So what is pub/sub logging? Essentially, you have a broker in the middle that is a, I would say, central entity that brokers messages between publishers and subscribers. Something happens on a chain, I send it to somebody else that processes downstream. Multiple, I would say, subscribers can listen to the same publisher, and to make it a bit more relatable in our ecosystem, I'd say you can think of it, chains are pushing data into the broker, developers can have access to it, services can have access to it, and that way you decouple the decoding of the block and the capturing of the blocks, right? In other terms, we will have all the chains with n endpoints that have the raw data. The broker would, or the system around the broker would capture the data, and then we have one single stream of decoded, refined data that people can have access to and build their queries on top. What it means is the chains produce blocks. Instead of giving scale encoded data to developers, we give them a JSON that they're used to work with. And it would have the decoded extrinsics, events, and every data they would care about, right? There are many different solutions for how to choose the broker, how to define the topics, how to decode the messages, and what programming language we choose. After some benchmarking, some tests, and whatnot, this is what we settled on. This is what I will show you today. As a broker, we use a tool called NUTS, right? It does that very well. It's a very lightweight alternative to Kafka, to some of those who know that. As a decoder, we'll use a substrate sidecar. So instead of reinventing the wheel for each chain, we use a tool that is maintained by Parity, and that we have a, I would say, stake in making sure that it works right to decode the blocks. And as a programming language, we didn't make any assumptions. Anyone can use the programming language they want to interact with this system. The system architecture, roughly very simplified. So you have the RPC node on the left. You have 10 lines of Python script that are block listener. These will connect directly to the RPC WebSocket endpoint. And every time there's a new block, send a signal to NUTS. Every time there's a new block produced by a blockchain, essentially, NUTS would get it and will push it down further to another subscriber that would do something with that information. What we can extend after that on the right, so whenever there's a new signal, a block fetcher service would get the data from the substrate sidecar and push the decoded data down to NUTS. How this works in essence, and it looks complicated, but it's actually very composable and simple to set up. You have two custom components. The block listener, which is 10 lines of Python. The block fetcher is, I don't know, even less than 10 lines of Python. That essentially does GET requests to the sidecar and pushes decoded messages down to downstream services. You can connect NUTS to a database, like ClickHouse, and have immediately access to the contents of the blocks in a database and use the same queries that you use in .lake to see, for example, did the validator change their stake? Did something else happen in the ecosystem that we already know we want to investigate and have a look at and use SQL to query that? You can also push the same data stream to a web browser at the same time. So this can be accessible for a dApp, for example, or any developer that opens a screen. What this enables on top of the monitoring is essentially we're pushing out a live real-time data stream to the ecosystem, and anyone can plug their services in with any language they want or with any tools they want to have access to this data and do whatever they want. This way, we don't decentralize the monitoring, but we can distribute it. That means any team can add their, I would say, their endpoints or a list of their endpoints to this .sentry tool, and anyone in the ecosystem has access to that data in real time, without any overhead, without any changes to the system, I would say. That way, any developer that has a, I would say, exotic use case and wants to monitor something very specific can use this data to build out their logic without bringing everything down or without having to update anything, because the decoding is abstracted from what you get here. Everything you need to take care of is the logic, right? So as I said, distributed view of the ecosystem health, so including common good data feed that contains the blocks, storage function results, and all of that. You can define real-time metrics and alert, and ultimately down the line, you can do drill-down capabilities because you see all the ecosystem at the same time. So you can see if anything happens to Polkadot, does it affect the parachains or the other way around, right? So an example of this is what I mentioned. So there's a web browser application. It's just JavaScript that watches in real time the blocks produced in the ecosystem, and by subtracting and adding the blocks, the consecutive blocks, you can calculate the block time. How long did it take for a block to be produced? And that way you can chart a graph and see, okay, are the blocks slower than usual, faster than usual, what is actually going on? You can do this in parallel for all the chains at the same time, right? This is live and available. If you want a more detailed write-up of what I just explained, there is a forum post with this, with code example and everything available that you can try out. So this is the visual thing. This, any developer can build it, integrate it into their application without any constraints. As long as you know how to deal with JSON, you can deal with this. So the next thing that I wanted to show, come on, yeah, is the same access you can get on your browser, you can get in the command line. Because usually you start a command line interface, and then you could want to get access to the blocks. So I prepared it here. Here we want to get all the blocks from Polkadot, from the system chains, from the parachains. We want to get the blocks and every new block number that is created by the chains themselves. This is piped directly into your terminal, so you can maybe, I don't know, pipe it into JQ and do something further with it. But this is a simple indication, are the blockchains, are the chains running or not? Are they slow or not? Similarly, you can create something where you want access to the content of the block, not just the block numbers, because that's maybe not useful information. The same way, the decoded sidecar data is piped into the nuts, and you can get it here, for example, for the Polkadot relay chain, and you can get it also for other chains as well. It's a lot of data, so that's why you can process it however you want. And the goal of this really is, again, this real-time data feed for the ecosystem without any overhead. OK, so now back to the presentation. We have 10 minutes. We should be fine. So what we solved with this is just bring your JSON parser and you have real-time data for the ecosystem. You don't need to deal with metadata upgrades. You don't need to deal with versions. You don't need to deal with Polkadot.js. Nothing, right? You just start your script or connect to the UI, and you have real-time data anywhere. So there's a lot of work that we can do, to define topics, do data models, and all of that. So it's still early stage, I would say, but it's usable right now, and you can start connecting to it immediately. How does this stabilize anything? So as I said, it gives us visibility, what is going on. Instead of having multiple tabs open with Polkadot.js apps, you have it in one view and see immediately if there's an issue in the ecosystem. You see right away, hey, the blocks are slow since the last upgrade, within 10 seconds of it happening. And you don't have to wait for the data team or anyone else to make a query and say, hey, the past week's blocks were slow. So we can react faster. This leads to faster issue resolution. So already seen issues should ideally never happen again. So if you see them we write the test for it, and then we catch them immediately. We can have alerts too, so more confidence into our system. So we can also use this same, I would say, approach to test not only what Polkadot is doing, but what people can do on top of Polkadot. So similarly, you can run the transactions against the chain and compare in real time what the effect was. If the effect is different than what you would expect, you can, I don't know, raise an alert and ask people to investigate. So one example of this is scheduling functions that would test if a transfer is successful. You can do that all over the time, every, I don't know, 10 minutes, and then see if there was any change in behavior, change in latency, change in whatever. You can measure everything. This helps us essentially, to make sure that Polkadot is engineered to be stable by adding all this ecosystem around it to measure these things. Additional goodies that we can do with this sort of architecture. I told you that we can distribute the monitoring. So since NATS is our central broker, anyone can run a NATS that would essentially not peer, but connect to the NATS that we have, right? So we can have leaf nodes of this NATS. If you're just interested in 3 chains data, you can filter any messages and just get that, and work on top of the same abstraction layer. So it's a way how we can broker data within the ecosystem, not decentralized, but distributed, and it should work relatively well. What you can build with this right now, as I showed you, you can do real-time Block Explorer in 10 minutes. For Block Explorer, the only important part is getting the data, having the data correct, how you display it, how you show it, how you persist the data, that's up to you. So no constraints there. What is also missing, and I think when you read the forum post, is there are some details that we still need to iron out, right? Right now it's an alpha. We need some bit more work in massaging the data and the data topics, how we want to model them to make sure that we provide solid access and reliable access, especially if we upgrade this system. We need a procedure to add new streams. So there's a new chain that want to be integrated. They make a pull request with their nodes, and automatically they get their live data. And of course, connecting to long-term storage. If you want to do, I would say, I forgot how it's called, but if, huh? Yeah, sure. You could connect any type of node essentially to it, but you could connect to like if you have the ClickHouse data that you get real-time stuff in, you want to compare with the historical storage to make moving averages over the past hour, over the past 7 days, over the past 100 days, something like that. So definitely, that having archive nodes would be fine unless you persist the data already in a SQL type database. So again, no constraints there. Yeah, and what we need to do is open source it. So you can give us your feedback, try it out, and tell us, are we doing something that makes sense or not? Similarly, we want to have a public, page that would show us what is the SLI, SLO of Polkadot, right? What can you expect when you come building on Polkadot? Can you expect something stable? If yes, how stable? And quantify all of that. Similarly, automated issue detection, notification. If there's some sketchy thing happening on a bridge, we want to be notified immediately, right? Because there's a lot of value behind it, a lot of people putting their businesses on top that we need to make sure is very solid. Better incident responses processes. This is the actual work after the technical stuff is ironed out. And of course, collaboration, knowledge sharing with all of you. Future enhancements, so expanding data sources and integrations. We just don't want only the block data. We want also node data to be available. What versions are most of the nodes running? How is the P2P chatter looking like? Is there anything unusual going on? That way, we monitor not only the contents, but also the nodes themselves within the ecosystem. We want to monitor version updates. Whenever there's an upgrade, we want to see how does it impact and affect the Polkadot and the ecosystem. And we can, build products like an RSS feed for changes that could impact whatever. So we are notified ahead of time if something might change expectations. And then, yeah, of course, a funny use case would be like anomaly detection. So we can write scripts that say, hey, moving average looks weird. Funds are moving in a way that is not expected. Then we can advise. So I would invite us to build with us. Of course, this is just the current state. This is not the perfect state. We can improve it and work on it together. There's a version release, so I invite you to read the forum post, ask questions there, or reach out to me anytime if you have doubts or concerns, or if you would like to get access right away. Voila. Thank you very much, everyone. And that was my talk. Sure, yeah.
Okay, yes.
I think there is a question. Yeah.
Thanks a lot. That looks very promising. Is it on? Yeah? Okay, it looks very promising. Anything, so I'm not until sure I understood. So obviously for real time, amazing, but how long does it go back? Do you start like dropping data once your Kafka queue gets too big? It's not Kafka, it's something else, but
yes,
once it
correct. So this PubSub is without persistence. So we don't store the data. We're just interested in maybe the last 2 hours. And the rest we drop, right? So if you want to persist it, you need to have a dedicated database to store things. Yeah.
So 2 hours is not a long time, because imagine, for example, that I'm running some infrastructure on top of that,
yep.
right? And I have an outage for 3 hours, I'm screwed. So 2 hours does not sound like enough. Like at least 24 hours, please.
Okay, well, there's literally no constraints. These are parameters that we can set. So if 24 hours is consensus, we can try that. It needs to be a trade-off with something that people can run without breaking the bank, right? We need to make sure that this can run. Like right now, I have it for 15 parachains. It runs on a 4 gigabyte VPS for, I don't know, $10 a month. So this is the kind of cost we should aim for. If 24 hours fits in the bill, fine. Otherwise, anyone can choose how long they want to persist it. As I said, if you have a leaf node connected to our nuts cluster, you can persist it forever and don't have to deal with decoding, backfilling, and all of that. Unless our things fail, then yeah, then we need to do some backfilling, but hopefully not. Yeah.
Any other question? No?
Yeah, perfect.
Well,
Thank you.